Welcome to this explainer. Today, we've got a real ecological whodunit on our hands. We're going to explore how completely life-giving elements can silently turn into massive environmental hazards, and more importantly, how we can systematically shut that down. I'm really glad you're here, because understanding these systems is absolutely crucial to protecting them.
We're starting right off the bat with this crazy tipping point paradox. In small amounts, these nutrients are absolutely vital. I mean, they literally fuel life. But when they build up too much in our lakes, our rivers, and our coastal waters, that buildup causes massive ecological damage. It's all about balance, and right now, well, a lot of our waterways are losing it.
So let's ground ourselves in exactly what happens when these specific elements overrun the system. We're talking primarily about nitrates and phosphates here. When those levels get elevated, they overfeed algae, they deplete the vital oxygen in the water, and they choke out local wildlife, sometimes even brewing up some really dangerous toxins.
Here is our agenda for today. First, the hidden water threat. Second, tracing the nutrient sources. Third, stopping nitrates and phosphates. Fourth, treating the system. And finally, number 5, the blueprint for clean water.
Section 1. The hidden water threat. Let's look closely at what is actually at stake when our ecosystems lose this delicate equilibrium.
When nutrient pollution hits a waterway, the chain reaction is incredibly swift. It feeds massive amounts of algae and aquatic plants. It aggressively crashes vital oxygen levels. It chokes out fish and local wildlife. A single massive algal bloom can actually suffocate an entire pond in just a matter of days. These aren't just minor hiccups. These are disastrous, systemic alarms requiring immediate attention.
Section 2. Tracing the nutrient sources. You really can't stop a leak if you don't know where it's broken. So we need to play ecological detective for a minute.
There is a stark contrast in how these two nutrients travel. For nitrates, they often seep into the water from agriculture, your everyday lawn fertilizers, animal waste, leaking septic systems, and industrial discharges. Phosphates, on the other hand, frequently hitch a ride on household detergents, fertilizers, food and organic waste, and crucially, sediment that gets stirred up by erosion. Taking control means addressing these specific, dominant pathways.
Okay, so now that we know the culprits and exactly how they get in, we have to ask ourselves a huge question. How do we step in and actually stop this cycle of damage? How do we regain control of our water?
Section 3. Stopping nitrates and phosphates. Lowering these concentrations is all about strictly controlling the inputs and radically changing how they are applied.
Let's start on a local, individual level. For homeowners, controlling nitrates means ditching the guesswork. You have to rely on precise soil testing first. Apply fertilizer only when genuinely needed. Split those applications so you avoid washing one heavy, toxic dose straight into the storm drain, and really lean into high-quality compost and slow-release fertilizers.
Now, zooming out to a larger scale, agriculture requires much stronger structural interventions. Farms need to install buffer strips and vegetated waterways to literally intercept that runoff before it hits the river. It requires prompt collection, treatment, and storage of manure. Operations have to utilize highly precise nutrient planning based on actual crop demand, and crucially, planting cover crops to capture residual soil nitrogen during the off-season is a game changer.
Now, unlike nitrates, which easily wash away, phosphorus acts very differently. It binds incredibly tightly to soil particles. Because of that, controlling phosphates is largely about preventing soil erosion. Mulching, stabilizing bare ground, maintaining surrounding vegetation, and managing leaf litter are super powerful tools here. And obviously, limiting what enters the system by just choosing phosphate-reduced or phosphate-free products makes a massive difference.
Section 4. Treating the system. Because, let's face it, what do we do when nutrients are already compromising a wastewater facility or an engineered pond?
When prevention fails, the treatment has to perfectly match the chemistry. To combat nitrates, we use biological reduction, specifically denitrification, where microbes in a low-oxygen environment literally convert nitrate into harmless nitrogen gas. For phosphates, we pivot to chemical precipitation. That means using iron or aluminum coagulants and absorption media to physically bind and remove the phosphorus.
Section 5. The blueprint for clean water. Let's tie this entire closed-loop system together into some truly actionable steps.
Think of this as your core defense strategy. Ongoing monitoring is absolutely essential because even the best controls fail if conditions change.
By testing indicators like nitrate levels, turbidity, and dissolved oxygen, we can spot trouble early. And when you see triggers, like heavy rainfall right after fertilizing or construction exposing raw soil or a failing septic tank, you must act fast. Making quick corrections during those high-risk periods prevents a disastrous nutrient pulse.
So here is a practical 5-step checklist to turn this systemic problem into a daily habit. 1. Test first so you aren't guessing. 2. Cut inputs by reducing products and adjusting your timing. 3. Stop runoff by maintaining vegetation and stabilizing soil. 4. Treat smartly by matching the exact biological or chemical method to your system. And 5. Monitor consistently and adapt to whatever changing conditions get thrown your way.
That brings us to our core philosophy. Nitrate and phosphate control is ultimately a system problem. Prevent nutrients from entering, manage them within the system, and verify results through monitoring. We really have to view water quality not as a static resource, but as a dynamic, living system that we directly influence every single day.
So, I want to leave you with this final thought today. Are your daily choices feeding the balance of your local ecosystem, or are they pushing it over the edge? Whether it's taking the time to test your soil before treating your lawn, or just reevaluating the detergents under your sink, you hold the power to shape this system. Thank you so much for joining me on this explainer, and until next time, keep asking the right questions.